This is mini project for Electrical Liability 2 by Group 5 from Section 6. Our group have 3 members. The first one is Muhammad Aiman bin Abdullah alias Muhammad Shukri. His metric number is DN240126. Second is me, Nabiha binti Zubatuwahan. My metric number is DN240012. Lastly, Muhammad Zaki bin Abu Bakar Siddiq. His metric number is DN240093. In this mini project, it is done in group. Each group must build a electrical circuit that has at least 2 transistor unit. Our group circuit must not be in the same as the other group circuit. We make this circuit experiment and made by simulation and physical. The circuit start with a simulation test and then it physically assemble and solder. The physical circuit has that been complete is tested again.
Assalamualaikum and hi, my name is Nabiha binti Zubatuwahan. My metric number is DN240012. Firstly, I will talk about power supply. The first main function of power supplies is to provide adjustable DC voltage and current. You can manually set the voltage and current for each channel. For example, you can set output 3 volt, 5 volt and 12 volt depends on your circuit needs. Second is dual output channel. Slave and master channel provide two separate output. You can use independently for two different circuits in series to increase voltage, in parallel to increase current. The third is digital display. Show voltage and current for each channel. In the photo, left screen show the 3 volt is set, current is 0 because it's not load connected. The right screen is 0 volt and 0 ampere because it's not in use. The fourth is CV, constant voltage, maintains a set voltage regardless of the load used when a fixed voltage is needed. CC, constant current, maintain a set current and the voltage adjust as need, used to limit current to protect the device. Lastly, safety protection. Built-in overload and shortcut protection for safety protection and it keeps connected device safe. How to use power supply? If you are testing a 5 volt sensor, you will turn on the power. Second, set the voltage knob to the 5 volt. Set the current limit 0.3 ampere for safety. Connected the red terminal to the sensor V plus and the black terminal on the ground. Press on or off to supply power. The main function of the function generator is firstly is to generate different waveform like sine, square, triangle, ramp, pulse, noise and arbitrary signals. You can select the desired waveform using the FUNC button. Second is adjustable frequency. It allows you to set frequency value like 10 kHz shown in the image. Use the FREQ button and numeric keypad to change frequency. The third is adjustable amplitude and offset. AMP button adjusts the signal amplitude. Offset button is add a DC offset of the signal. The fourth is output signal. The signal is sent through the BNC output port to your circuit or device. Press the output button to turn the output on or off. Then, modulating function. It is include AM, FM, PM, PWM, and sweep option. These are used to communication and testing application. Next is memory or storage. You can store and record arbitrary waveform using internal memory. Lastly, bruise and sweep mode. Bruise send a fixed number to the waveform circle. Sweep gradually change frequency over time, useful for testing filter. Then, how to use function generator? First, turn on the device using the power button. Then, connect the output to your circuit for oscilloscope using BNC cable. Press FUNC to choose waveform like sine, square or triangle. Press FREQ to set the frequency, for example 1000 Hz. Then press AMPL to set the voltage, for example 5 voltage peak to peak. Lastly, press output for turn the signal on. Oscilloscope. The main function of oscilloscope is first is to display voltage with this time. Show how voltage changes over time using a graph y equal to voltage and x equal to time. Second, you can measure waveform property. You can measure amplitude, voltage level, frequency, period, rise or fall time, and phase difference. Then, you can check signal shape. You can see if the signal is sine, square, triangle, or distorted. Next, troubleshoot circuit. You can find error like noise, glitches, or unexpected signal behavior in electronic. Lastly, compare signal. You can use two channels CH1 and CH2 to compare signals side by side. How to use oscilloscope? Firstly, you need to turn on the oscilloscope. Then, connect the probe to the input channel CH1 or CH2. Then, attach the probe tips to your test signal or form function generator. Press auto set to automatically adjust the display. Use the vertical knob to adjust voltage scale, y-axis, and use the horizontal knob to adjust time scale, x-axis. You can now see the waveform like the sine wave in the image.
So for the component, we use resistor 2.2K and 100K, push button, BC547 NPN, BC516 PNP, capacitor 33 UF and 45 UF, and LED. So for the circuit diagram, the circuit functions as a simple LED delay of system. When the push button is pressed, it activates the transistor, turning the LED on. After releasing the button, the charge capacitor keeps the transistor conducting briefly, allowing the LED to stay on for a short time before gradually turning off as the capacitor discharges.
For the soldering section, in figure 1, the solder tool, we use the soldering iron, dump spoke, tack tip, solder wire, and solder cycle. For the figure 2, the proper soldering technique involves the tip push the pad on the PCB board and the component lid, and the solder wire on the opposite side so that the solder will melt into the joint. Okay, for this part, show how I solder and the result of the soldering done. The connection must be soldered well to achieve a good joint, because if the component is poor, it will affect the current flow and the function of the component.
So for the next result, when we push the first push button, the LED will be blinking, and if we push the second push button, the LED will stop blinking and turn on. After we release it, the LED will continue blinking, and if we turn off the push button first, the LED will turn off.